Good morning, everyone. Thank you for conquering your hangover and coming this morning. No, it's not easy. My name is Yaniv Rodenski, and I've been developing a distributed application on Mesos for the last 9 months, and I want to talk to you about that. First of all, we tend to think about building distributed application as that thing that we do when our stuff don't fit into one computer anymore. And that's one of the reasons why we need to scale out and build distributed application. It's not the only reason why we build distributed applications, right? Even if we would have this giant, enormous computer that can hold all of our computation and all of our data, we'll still have one electrical cable going into the wall somewhere that someone can plug out, and that's a single point of failure. We still have users from multiple locations in the world, so we need to be geographical distributed. So there's a lot of reasons why we need to build distributed applications. My specific reasoning was the fact that I'm dependent on other distributed applications when I started writing my own distributed application. But it's not easy. It's the exact opposite of easy. I didn't come up with this analogy of distributed systems as herding cats. The first time that I heard about it was from this research paper that Yahoo published on Apache Zookeeper, which is another infrastructure that they built for distributed application. It's actually being used by Mesos. That is, we're going to see that a little bit later today. That is a quote from that paper. I just learned too late from Scott Hanselman that I'm supposed to put a picture of someone. But definitely, it sometimes feels like that. I have 2 cats at home, and it feels very much like herding cats. And the reason for that is that we need to deal with a lot of things that we don't deal with when we're building applications that run within a single computer or are very trivial. So, for example, we need to deal with network communication. Network communication is something that we've been doing for a long while now, and we feel like we have it under control. We have heaps of frameworks that deal with network communication. But the fact is that when that network communication needs to give us the same attributes that local programming does, like guarantee that our message has been received on the other side, that is often very complicated. And we need to give up a lot of things that we don't think of. We need to deal with things like fault tolerance that we don't deal when we're working in a single process or multiple processes on the same computer. And that introduces a lot of complexity. We need to deal with synchronizing our different services and parts of the application. And that, again, introduces a lot of complexity. Deploying an orchestration of a distributed system is, again, very complicated. We need to control a lot of moving parts, and we will see a lot of moving parts through this talk. And that's just another thing that we need to deal with. And for all of these, by the way, we have solutions in the distributed world. We have frameworks and tools that help us deal with that, and things like monitoring that we need to deal with. Once again, much more complicated in a distributed world. And last but not least is the issue of resource consumption and governance. And that is something that we are going to talk about quite broadly this morning. So I apologize for that, but at a certain point in a presentation, you can't stop a running joke. So building distributed system is not easy. With that said, we have a lot of different tools and frameworks that help us to do that. But we are going to look at Mesos, and Mesos gives us a different paradigm for building distributed systems. And that paradigm is, in my mind, very powerful and very interesting. So what is Mesos? Mesos is a distributed system kernel. Remember that definition? Because Mesos acts and is designed as a kernel, as something that you treat as a part of an operating system. It started as a PhD research project by Benjamin Hindman in UC Berkeley, part of something called AMP Labs. And there are lots of interesting projects that came out of that. I'm going to talk about another one in a bit. It started in 2011, and the whole idea of Mesos is to allow developers to think of their data center, as the clusters, as a single machine. So it really does introduce a lot of the concept that an operating system will introduce when you're working against bare metal. One of the focuses of Mesos is fine-grained resourcing, okay? And that means that Mesos basically tries to give us more control on the resources that we consume across our data center. And it grew in Twitter and Airbnb. Okay, it started as a research project. Benjamin Hinman, if I'm not mistaken, worked at Twitter at that time. Twitter widely adopts Mesos. In fact, as far as I know, all of their code runs on top of Mesos these days, or the vast majority of it. Airbnb, again, as people shift between those companies, started to adopt Mesos. I know that today Netflix are using it as well. So it's being used at really large scale, but the origins of Mesos actually, like every interesting problem in computer science these days, actually originated in Google. And Google has been using this infrastructure in their data centers for a long time. It used to be called Borg, replaced with a newer version now that is called Omega. And they've been using it for a long while. We don't know a lot about it. Google are usually very secretive about their internal implementations, but we do know a bit now, and it's a bit more than we did when Mesos started to come out. So in 2013, Google actually published a paper about Omega and what they're achieving with it and how they're working with it. But there's another interesting thing that came out of that whole project, which is something that they donated back to the Linux kernel, and it's called C groups. Okay? And C groups are one of the foundations of what we know as modern containers. So what's the problem that they try to solve? When we're thinking about our applications in our data centers, naively, we usually, when we whiteboard or PowerPoint or whatever we do, we think about them like this. We have a cluster of something. Let's say we are using a distributed database, bless you, like Cassandra. Okay? So this is how we envision it. We're going to have, let's say, 5 nodes. And this is something we can scale, right? Cassandra is a scalable database. We can scale it. Obviously, for our databases, we'll use specific nodes, right? We need fast disks. We need good IOPS. We probably need fair use of CPU, and we need memory. Okay, that's one profile of machine. And then we'll have our web services. Let's say we're using Apache Tomcat for that. And those are actually very easy to scale up and down, right? It's very easy to understand what's going on with web services and web applications. We can analyze the requests that are coming in, and we can kind of analyze the resource consumption for those. And then we're probably going to have some sort of a caching mechanism, and maybe we want to run analytics, and we'll use Apache Spark because no one uses anything else these days. That is how we tend to think of our data centers. The truth is that they look more like this, okay? And there's an issue with that. There's an issue with that because in this situation, we're actually not using all of our infrastructure. In this situation, we're actually holding a lot of infrastructure for things like our database and our web servers that they're not using, right? And databases, throughout the years, kind of lived in that feeling that, you know, I'm going to take all the memory that I can on my machine because it's a database server. I'm going to use it. If I'm not using it, I'm not going to bother with allocating and releasing it. Once I have a memory, I'm going to use it. But it is very useful, very wasteful, sorry. It's very wasteful in resources, and Google is not the kind of company that will just waste resources. So they came up with Borg, and they came up later on with Omega, and Mesos kind of was inspired by those projects. So we'll talk about the Mesos implementation, and Mesos takes 2 things from Borg and Omega, And that's two-level scheduling, which is very important. And another thing that we all by now understand is very important is containers. So this is how Mesos runs your application on a cluster. This is what Mesos tries and most of the time achieves. And if we look at that, it's not easy. It's not easy because of all of those assumptions that we have. The assumptions that we need different machines for different services, the assumption that some services live in a world of their own and just don't think about sharing resources, and the fact that we just didn't have the mechanisms for a long time. So systems that run on top of Mesos are regarded in the Mesos terminology as frameworks. And we can write our own frameworks in a variety of languages. Actually, to write a Mesos framework, you only need to be able to hit HTTP APIs with Google Protobuf objects. So if you can do that manually, you can use whatever language you want to use. There's support from the project itself for C++. Mesos is actually a native application implemented in C++. The JVM, Python, Go. I've seen just this week a new release from the community, actually from one of the contributors of Mesos in Node.js. There's Haskell, there's Erlang, there's a variety of languages that you can use. And as I said, at the end of the day, what you need to do is just to hit HTTP endpoints with Google Protobuf. And the thing that you need to do, or the object that you need to create, the two main components of a Mesos framework are a scheduler and something called an executor. Okay, and the scheduler for us will be kind of our master in the application. A scheduler is the thing that gets from Mesos something called resource offers and basically schedules everything and orchestrate between the different moving parts. Executors actually execute our application. So let's see how it works in more or less real life. We have a master for Mesos. This is a daemon that runs somewhere in your data center. And your application, let's say we're looking at Apache Spark, has a scheduler. Now the scheduler has some work that it needs to distribute. So it goes to the master, it registers with the master, and it starts receiving something called resource offers. Resource offers, and we're going to see those in just a little bit, are just the master's way to say, I have on this computer 3 CPUs and 4 gigs of RAM I can give you. Is that enough? And based on what the scheduler needs, or what the framework needs, the scheduler will decide if it want to accept the offer and basically launch something on a Mesos slave. By the way, in the latest version, they changed the terminology. Apparently, it's not politically correct to use master and slave in distributed systems anymore. They also reject my offer to use architect and developers. But so these things are now called agents. So we have master and agents. So we're semi-PC. But in our slave or agents, we have something called an executor. And an executor is just a process that is being run by Mesos for us, and it executes a task. A task is a unit of work. It's a logical thing. It's not necessarily is something physical. We're going to take a deeper look at those. And then we have another framework. Okay? For example, Marathon, which is one of the probably one of the basic ones that you will be using if you're using Mesos. And Marathon needs to execute something. Again, it registered, first of all, with the master, and then it starts receiving offers. And yep, there's enough resources on this agent, so it's just going to spin up its own executor and its own task and do some work. Until now, we're looking at executors and tasks as a one-to-one kind of things, but in fact, it might be that when we need to run another task, we are hitting a slave that already has an executor, so we don't need to do that. We don't need to create a new process that runs our application. It might be just another thread. And so on. And as you can see, this way we get two things. First of all, we have this way for frameworks to get resources with the understanding that they can use it. They're not taking the memory, or they're not taking the CPU or the drives or network ports from anyone else. There's a Mesos master that orchestrates everything, and once a framework receives an offer, it can assume that it's okay for it to receive it. So we can scale up, we can scale down very easily. And by the way, if we look at this, there still is a single point of failure here, of course, the Mesos master. So Mesos supports multiple masters. And in order to elect the master, because in those kind of systems, we can only have one master, right? We can't assure that two masters see the same things, and we can't, basically that situation is called split brain, when one master will give us resources and another master will give another framework the same resources. So we use Apache Zookeeper that, by the way, comes in smaller font in real life. And Zookeeper actually has a master election primitive within it, and that's what Mesos uses to select the master. I'm telling you this not because it's very interesting from the internals point of view of Mesos. It is interesting because we can assume that we have Zookeeper around when we're running on Mesos. It's actually very exposed in the APIs, and if we want to use Zookeeper for our distributed application in addition for what we're using in Mesos, we don't need to care about it. We can actually get the details of our Zookeeper nodes, the quorum, and just use that as a given in the environment. So let's take a look at how a scheduler looks like. Apparently, there's a problem with the network here. Yes. Always. So this is a very simple implementation in Scala. And actually, to have our scheduler, we do need, in the JVM world, two parts. So we have this launcher. This launcher is just the entry point. This is the main function, right? If you're looking at any other language, even in Java, you will have a static object with a main that receives args. This is Scala's way to say we're different. And there are three things that we're doing here. First of all, we're building a protobuf object that is going to be serialized and used internally by Mesos that defines our framework, right? So we're just giving it a name, and this is something we'll be able to follow in the Mesos UI. Failover timeout, okay, and this is actually important because we want Mesos, or we want to control the amount of time that Mesos consider an executor to be failed, and we want to control that. So if Mesos see that an executor is failing or can't get any response from it for 10 seconds, then it will fail it over and restart again. And the user that will be used on the framework. So this is the user that will be executing on the slaves or agents themselves. And then I'm just creating my scheduler, okay? We'll take a look at the scheduler, but this is just an instantiation of a Scala class. And we're using the Mesos scheduler driver to actually register with the master. So we're giving it the scheduler, the framework, okay, the protobuf object, and the IP of the master, and run. Once we do this, we can go into our Scala object, and there are two things here. This is just a companion object in Scala. Think about this as a constructor, and just naively, I'm giving my constructor a list of videos to download. I know how much the Australian government loves us to download movies, so I've built a distributed application that can download movies in parallel. Because I do revere my visa, I'm actually going to just download movies that I've taken from my phone, but if you want to download movies in parallel across the data center, you can actually use this framework in production. And this is the scheduler. Scheduler just extends a Mesos object called scheduler. And we have a bunch of functions here that we're going to implement throughout the demos. The first one is registered. Okay, so this happens once we're registered with the master. Not very interesting. I'm just saving internally the framework ID that I got from Mesos for further use. And resource offers is actually a very important function. A lot of your logic will go into resource offers. What happens in resource offers is basically the master starts to send you offers. I have these resources on this slave. I have these resources on that slave. By the way, if you are writing a framework, pay attention. I suspect that we are going to see a bit of API changes because of the politically correctness of this. But basically, we're just getting a list of different offers. And for now, we'll just print them. And I beg you to do this. Because we are not going to use it, we're going to decline the offer. Now, this is important because of another aspect of Mesos. Other than our scheduler, there's another scheduler that goes and says, OK, I'm going to give these resource offers for X amount of frameworks. And I'm going to schedule between them. Now, there's two things that can happen, or three things that can happen. We can accept them, we can reject them, or we can just wait for the offer to time out. But if we're waiting for the offer to time out, someone else is being deprived of that offer. So if you're not using an offer, and I'm going to repeat that throughout the demos, please decline it. So let me just build this. And while it's building, I have this vagrant machine that runs single node Mesos. By the way, at the end, there's the Git repos for both the demos and the vagrant machine. So if you want to try this, you don't need to set up your own Mesos cluster. You can just clone that repo, vagrant up, and you should be good. And for me to run this Java application, it's just Scala is just a Java application. All I'm doing, I'm using Java CP. I'm giving it the jar file. Launcher is my entry point. That's the class, the main class that I'm going to execute. And here's a little bit of a dirty secret from the Java or the JVM implementation. Basically, what they're doing, they're wrapping the native library in C. Okay, this is very specific for the JVM if you're using. If you are, you need to pass in the Java library path because in user lib, we have the libmesos.so file. So once I run this, I'm starting to receive offers. And you can see that I'm getting these offers. This is the framework that received it. This is the slave ID. The host name for that I might need to use, right? I might need to communicate with that node on this host name. Resources, I'm getting a memory. I'm getting a disk. And by the way, you can see that we actually have mainly three types of resources. We have scalar. Okay, so if we're taking a CPU, that's a scalar value. We have range, and ports can be range. We also have a set, so if it's not a continuous range, we can just give it back those specific values that we need, and so on and so forth. These are the resources that we're getting back from Mesos. So, because, actually, almost forgot to show you. This is the Mesos UI, and this was my framework. So I can actually go through, and there's not a lot here right now. We're going to add functionality. So I can actually use this web UI, which is, by the way, I've just learned, is responsive. Things you learn when you plug into a projector. Okay, so let's do some stuff with our framework. Okay, so we want to download movies. So again, all of the magic happens in resource offers. So we're getting the list of offers. Now I'm going to actually look at the offers and analyze if they're good enough for me. For downloading a movie, I don't need a lot of resources. So I'm just checking. I'm checking that I have more than 0.1 CPUs and more than 128 megs of memory, which is, by the way, I think even more than enough for what I need. Now you notice that I'm looking for 0.1 CPU. And in fact, I can request that. I can tell Mesos Slave, it's very nice that you have 8 CPUs. I need 0.53, right? And I can actually go up to 3 places after the decimal point in Mesos. And the thing that allows me to do that is actually the use of C groups. Okay, so C groups is a feature of the Linux kernel that Google introduced, and they actually used it internally for Borg. And what that feature allows us to do, it allows us to take a process or a process tree and allocate resources for that process. And that means that that process will not be able to consume more resources than been allocated to it, but also that these resources are reserved for that process or process tree. And this is what Mesos uses. And this is what allows us to get that better granularity and better density from our machine. And if you think about it, the problem that they try to solve is the same problem that the cloud tried to solve on a data center scale, right? The problem with data centers, with traditional data centers, were that we needed to buy the hardware for our peak times, but we didn't use it, so we started to share the hardware. But the one thing that the cloud didn't manage to do is to take the same problem and scale it down to a physical machine borders. And that is what containers do, and that is what Mesos help us do on a larger scale. So we have our resource offers. We validate them. If we don't have enough resources, I cannot stress enough how important this is. Okay, don't bogart the cluster. It's being shared by a lot of applications. If it's not being shared by a lot of applications, you shouldn't be using Mesos. Okay? But if you are, please release your resources as soon as you can. Okay, so we're going to use, or we think we're going to use the resources. The next thing that we are going to do, we're going to take a look at our download queue. This is just a concurrent queue that holds all of our download URIs, and we're going to take the next one to download. By the way, the reason it is concurrent is because we get these offers asynchronously. So we can be processing one offer or a set of offers that we just received, and the master has a new set of offers, and he just throws it again to our scheduler. So we need to synchronize that. For us, it's just meaning using a synchronized queue. But this is a very naive implementation. Okay, if it's empty, again, I'm declining the offer. And for my framework, that's the end of its life. So I'm stopping the scheduler. Another thing that I want to stress, after I stress that you need to release resources as soon as you can, is that Mesos actually is built for long-running services. So if you think that this queue is going to get more downloads, or if your application is supposed to be continuously just living on your cluster, it's okay. Don't close the scheduler. If your executors are long-living, then leave them. Don't release them just because I said. Release them when it makes sense. Okay? But for our use, it's time to just stop the driver. And now I'm getting the movie. This is just a string that gives me the movie, and I have to build my task and my executor. And here's another thing that comes out of the box with Mesos. If our task is just something that we can run as a shell script, as a shell command, there's something called the task executor that comes built in with Mesos, so we don't need to even build our executor. And for us, we're just building a command, which will be wget, okay? And we'll download our movie. We've seen before that I'm just using print line to print to console. So let's try and print something from our executor. So let me just do echo. Movie. Okay, so I'm just going to run 2 commands now. One will just print downloading and the name of the movie, and the other one is the wget. And let me build this. Let's run it again. Before I forget, I actually need a web server to host the movies. So I'm just going to run the simple HTTP server, the Python simple HTTP server, but that will show us also what is being done, what is being downloaded from the server. And I'll run this again. Okay. So a couple of things that we see. First of all, we see that the task is running, the task is finished. We're getting a status update. And I forgot to show you this in the code, but we're actually registering for status update. Okay, this is another mechanism that we get out of the box with our scheduler. Okay, this is not what we're printing. This is something that we're printing from the scheduler. You can see that we actually don't see the print line that we had. One thing that is really helpful when you're working with Mesos is this. So when we're running an executor, it runs on a slave, on an agent. Now, in our case, it's a single machine, but not necessarily. So what Mesos does, it actually redirects std out and stderr to a sandbox. Sandbox is just a file system location that is being created for our executor. So you can see that we have here downloading and the name of the movie. This is the echo that we sent from the task executor. Another thing that we will be able to see here is the actual download, because I didn't, not very helpful, but, sorry, I can hit the download and we can see that it is actually a movie. Forgot there's sound here. Yes. Okay, so everything is being executed within this sandbox. The nice thing about the Mesos UI is that you can actually look at your sandboxes and see the stderr and the std out, and very easy to debug that way. And we have our scheduler. We actually have more than that. We actually have a very legitimate Mesos framework, because we are using the task executor, and it looks like something very simplistic, but it actually is something that is production grade. Okay, so things to remember about the task executor. A, it's being containerized. It's running within a container. Okay, and the second thing is that Mesos actually manages a lot of the life cycle. If it will fail, it will be handled like any other executor that is failing. It will try to reconcile, and if all else fails, it will actually fail. we see that we get the status updates. So the entire life cycle of the task executor is being managed. And if you have a distributed system that you just want to use Mesos for the resource management aspect of it, but the internal communication is already being managed, you can actually use that. And some frameworks use the task executor. It's a very legitimate solution. In fact, you are encouraged to use that until the point that you need more. And as I said, everything is being containerized. Okay? Containerized in Mesos is an abstract thing. Mesos has its own containers that are made out of C groups and namespaces. Namespaces, by the way, is another Linux kernel feature that basically determines what you can and cannot see from inside your container. But Mesos now natively supports also Docker, which actually is built on top of namespaces and C groups, but gives you all the benefits of Docker. So if you want to have a task that is just running a Docker container, you can have that as well in Mesos. But that is too easy, so we'll complicate things and write our own executor. So let's take a look at how that looks like. Okay. So to create our own executor, and this is again very specific for the JVM family of APIs, we need a launcher, okay? This is specific because again, Mesos need to bootstrap the Mesos lib. But we do more or less the same thing. We create an instance of our executor object, okay? And we're passing along, this is the URI to download. This is not something that we need. This is not the master URI or anything like that. And we also have a driver. We give it the executor, and we tell it to run. Our executor, which is for some reason shown as not being compiled. Once again, we have two main things that we want to look at. Register, okay, and this is just a way to basically get information when we're starting our executor. And the other one is launch task. Launch task is something that will happen every time that Mesos needs to create a new task. Okay, and for our task, I'm just going to use the ending HTTP client to download a movie, and I'm going to do something a little bit different. Okay, I actually want to notify my my master or my scheduler with something. So I'm going to use something called framework messages, and I'm going to send a message back to my master, or sorry, to my scheduler. It's getting very confusing at this point. So not a lot going on here. Again, we're just extending the executor. Our scheduler is a little bit different. Our command info looks a little bit different now. We're actually starting another Java process. But we also need that process or that jar that we're executing to be present inside the sandbox, right? This is going to be executed in the sandbox. So command info let us add resources. We're going to use the add URI and just give it our jar. It is actually being served from the same HTTP server. But you can use that for anything you need. If you have dependencies that you want to add, you can do that. You can actually mark it as executable or extract. Okay, so if you have a tar file or a zip file, you can just tell Mesos, just extract that once it's been downloaded in the sandbox. So once we do that, we also need to create this executor protobuf, okay, describe our executor. But again, the resources that we request go to the task, right? So if we have multiple tasks on the same executor, we can actually request different resources for each one of them. So once again, before we build this, there's another thing. Framework message. Okay, so framework messages is the internal communication mechanism used by Mesos. And love the network in this conference. Anyway, it's fairly easy to use. Okay, so we're just sending a message on one side, we're getting it on the other side, and it's a way for us to communicate. We can use that, for example, to send our executors more data. Okay, we can use it for a lot of, or to report something more specific back to a scheduler. But there's one thing you want to remember, that as opposed to starting a new task or starting a new executor, these are not reliable. You're sending them, there's nothing on the face of this earth that will tell you if the other side received it, okay? So you might want to use another communication mechanism, and nothing prevents you from doing that. In fact, you can get all the IPs of everything from the Mesos APIs. So let me just build this. Yes. And we don't have a network. Continue. Let me just use my phone. No, I don't not want to use Troy's iPhone.
That's asking for problems.
I'll have to skip this resource offer. Yes. So first of all, now we know that Telstra have budget for next year. But once we assemble this, and I actually have the jar ready in the HTTP servers folder. Sorry. I can now run this. And if we'll take a look here, you can see that the first thing that was downloaded is actually my jar file from that server. And then we're getting all of the movies. But if we go here, okay, or cd out, we can see, okay, I'm actually printing the response. Okay, so if we'll take a look here, right? Oh, sorry, wrong version of the jar. But I do have a print line in there to print a response. But I got the messages back. Okay, so now we have communication between our executors and our scheduler. Okay. As opposed to the Ned Stark one, I'm very proud of this. I actually searched for a cat like that for, I think, 2 hours. Okay, so a little bit about building executors. You do not necessarily need to do that. I cannot stress it enough, okay? If you're just gonna use the command line, by all means, use the task executor. It is great. But if you want to do things like run different tasks as threads and not as processes, and you might want to do that because you want to cache something on the executor level, as we do in our framework, that is definitely a possibility. If you want to use framework messages, that's another reason for creating your own executor, and whatever makes sense at this point, right? If it makes sense, just build your own executor. So, if we talked about Mesos until this point as a kernel for our data center, there is actually a full-blown operating system, and it's called DCOS. And one of the things that drove me into Mesos is actually not the capabilities of Mesos for building distributed applications. It's actually the ecosystem. And I was building a distributed application to orchestrate big data processing jobs, right? And there's a lot of frameworks that are running natively on Mesos. And one of the really easiest ways to get started with those is using DCOS, or sometimes pronounced DCOS. So DCOS gives us a lot of things. It gives us management tools and a nice UI on top of Mesos, a nicer one than the one that we've seen. It also gives us package management. So we have something called Universe that allows us to just select frameworks and install them on our cluster. We also have a really easy way to deploy this on our cloud. So I'm going to use AWS to show you DCOS. And there's just a CloudFormation template that you can use. By the way, it's open source as well. Okay, there is an enterprise support license and everything if you need that, but it's completely open source, and this is another very nice thing about it. So you can easily run it on Microsoft Azure. It's actually in the marketplace, so you just select it from the marketplace, couple of clicks, and you're done. You can run it on Vagrant, and if I had more resources on my laptop, that is probably what I would do. And there's a company called Mesosphere behind both DCOS and Mesos, and they're actually very good. In the resources slide at the end, I forgot to give you a link to their Slack channel, but they're very responsive and very helpful on Slack, and also their support. So if you just open a support ticket, without paying them a cent, you're probably going to get help. So let's take a look at how it all looks in DCOS. And so at this point, I think that I can take over even all of the screen. We'll do it like this. And this is just the DCOS master on my AWS. And first thing that you see is that I actually have to provide a login. I'll log in. This is me. I can actually log in as my wife, which is pretty cool. Next time.
It's a trap.
It is. Damn it, this is recorded. Okay, so this is the main UI for DCOS. We have a nice dashboard that everybody loves. We can actually see which services are running, and I mentioned Marathon briefly before. It's a framework for long-running processes on Mesos, and Marathon, long-running, and basically what it allows us to do is to create application, NDC, and you can see we can, for example, just give it a Docker image. Okay, so we can just have Docker images running on Marathon, and we can scale this up and down, and it is actually a very useful and a fundamental piece of Mesos at this point. Okay. But if we go back to DCOS, we can monitor our different nodes and universe. This is pretty cool. Universe is the main package repository for DCOS. You can actually use a public one or your own private one if you like. And as you can see, we have a lot of frameworks that are supported. So for example, if I want to run Cassandra, and I suspect I don't have enough resources on this cluster, I can do something like advanced installation and select how many nodes and give it the resources that I want to give each and every node. So we get a slightly easier way to install stuff. I'll skip this. By the way, data stacks are heavily invested in DCOS. Others like the Confluent platform. Okay, so we can see a lot of Confluent stuff going on here. Okay, are also very strong partners. You have Bitbucket. By the way, the Atlassian Cloud runs on Mesos as well. It's another company, Spark. And one thing, I keep going back to Spark. There's one interesting thing that you'll find. There's the research paper that Benjamin Hinman and Hans Stoicha and a lot of others published in 2011 talks about Mesos and talks about building framework that are built with specific schedulers. So they said, we're running things like Hadoop that has a very general scheduler on Mesos to prove the fact that frameworks with a specialized scheduler get better results. We built another competing framework called Apache Spark, called Spark back in the day before it became an Apache project, just to prove that frameworks with Mesos specific scheduler work better on the framework. And they did brilliantly. Now it's the go-to framework for big data processing. So that's another case. And really there's a heap of frameworks. So if you need the HDFS, or by the way, there's another Kafka implementation a little bit older than the Confluent one. Elastic, the entire Elastic stack here, so you can deploy separately Elasticsearch and Kibana and Logstash. And really, there's a growing ecosystem here. And for us, building a framework that actually orchestrates things such as Spark, there were very few choices for cluster management. And we went with Mesos, and to be honest, I couldn't be happier. So, building distributed system with Mesos is scalable, resilient, and for most of the times easy. I'm not going to bullshit you. There are hard points. Every time you're building distributed system, there are going to be times when you say, this sucks. But a lot of the pains go away with Mesos. It gives us better use of our cloud and our data center. And that means a lot. Okay, I know that we're brought to think that the cloud, we're just renting machine, we can scale up and down, it's not a big investment. But it does, it is, okay? Just think about all the resources that we're wasting. Now, I know that most of it is, for us, is money of our employers, but to be honest, that's electricity and resources that we also consume from the environment. And I actually feel deeply about that. There's also a growing ecosystem. Okay, you see a lot of companies investing in Mesos, building their application to run on Mesos, and we haven't started scratching the surface. I know for sure 2 CI/CDs solution that work on top of Mesos. I think that I heard of a third one recently, and it runs everywhere, really everywhere. So don't be afraid, and you're not confined to using AWS or whatever cloud you don't want to use.
Does it run on Azure?
Yes, it does. It's in the marketplace, and it's really easy to set up. For some reason, my Azure account doesn't work in Australia. So these are the demo, the Vagrant machine. DCOS.io has a really simple walkthrough for every deployment scenario that you want. The Apache Mesos website. And I also urge you, if you need, send Mesosphere support a ticket. They're really helpful. In fact, they actually sent me t-shirts, so I'm going to give those at the end of the talk to anyone that wants. So they're very, very helpful. And the Slack channel, so it's chat.dcos.io. And there's a lot going on there. They're helping people with anything from very beginners to people who are stuck in the dark points of Mesos. So don't be afraid to just ask questions, really. They're very nice. And that's it for me. I think we have time for a few questions. Yes?
So DCOS is just like an AMI on AWS? Like you can just
So,
spin up an EC2 with AMI?
so it's a CloudFormation template.
I see.
And really, it really is easy to set up. I actually set up 3 clusters this morning. I stuffed 2, but yeah. Yes. Yes.
Can you use this for infrastructure? Can you use Mesos for infrastructure creation tasks as well?
No, so Mesos runs on your infrastructure as basically daemons.
But could the daemons you could use to spin up infrastructure?
So
It's a bit of a meta thing.
I don't see why you wouldn't be able to write a framework that just executes Ansible commands or Chef or Puppet. And
Is that something suggested though? Like what would you?
I actually haven't thought of that. I don't see any reason why you shouldn't. So if you're using one of those frameworks and you want to distribute the load, at this point I'm starting to think it's actually not a bad idea. But you can let me know on Twitter how it works. That's it? Yes?
Just so I'm a bit lost between DCOS and Mesos. Basically, DCOS is on top of Mesos? Or?
Yes.
Okay.
So the analogy is if Mesos is the kernel, DCOS is the operating system. It gives you a UI, monitoring, governance. It gives you the package management and also the deployment. So you don't need to install Mesos. Actually, the DCOS deployment scripts for every platform will do that for you. Okay. Yes?
Sorry again. I would think that Amazon will have some sort of this kind of Borg stuff happening for them as well. Is that how they work? Like, because they have to assign resources to customers and all that.
It's a good question. I know that Google Cloud use Omega. I'm not sure what Amazon use internally. I know that there have been rumors about Microsoft moving parts of Azure into Mesos, and I haven't seen any confirmation of that. Okay, so it's all rumors. Everyone is keeping their cards close to their chest. But if you wanna, by the way, for a long time, Google actually took pride in the fact that if you're spinning up a service on Google Cloud, it takes seconds. Now we know that the reason that is that they're not spinning up a new machine, they're just spinning up containers, right? The secret is out. I suspect that we'll see more and more companies use this type of infrastructure. And by the way, Mesos is not the only one, but first of all, for what I did and from what I've seen the comparison with others and played, I've worked with Yarn, which is very specific for the Hadoop stack for years, for many, many years. I can tell you that Mesos performs way better than Yarn. Okay? Comparing to Kubernetes, I don't know. I know that Microsoft just hired one of the main architects of Kubernetes for their internal needs. Okay, it's not a product that they're gonna push. It's for the Azure Fabric team, which is the internal infrastructure that does that. So all of them will have to use something like that at the end. They wanna save resources. That's the main, the main need of the cloud. And it just makes sense that they will go into the boxes after they solve the data center scale thing. Okay, so that's it for me. If you want to have DCOS t-shirts and stickers for your laptops, come to me after the talk.